everyone, and welcome to our lesson on solving rational equations. When we talk about rational equations, we're typically going to see equations with some fraction expressions. So our strategy for these is going to be to factor your denominators, if possible. Then you're going to find the least common multiple of those denominators, and you're going to multiply both sides of your equation by that. And then you're always going to simplify, look for things to simplify and cancel out, solve for your variable, which means to get the variable by itself, and then you're finished. So we're going to take a look at an example and use those strategies. So we have 3 over x minus 2 equals 9 over x squared minus 2x. So we've got a rational equation here. And remember, the first step was to factor out our denominators. So we can see on the second side over here, that can be factored a little bit. So let's rewrite what we have. 3 over x minus 2 equals, I'm going to change the look of this to be x times x minus 2. Because they share an x, so we can pull one out to the front of a group and put in the group whatever's left. And what's left is x minus 2. All right, our next step for our strategy was to multiply both sides by the least common multiple of the denominators. So that's going to be x times x minus 2. The least common multiple is going to need to contain each different piece that you see in your denominators. So we're going to set that up here. So our first side, our left-hand side, needs to be multiplied by x times x minus 2. Okay. And our second side does as well. And the reason why we want to do that is because we actually need these fractions to go away so that we can continue to solve. So by doing this, a lot of items are going to cancel and allow us to proceed to get our variable by itself. So you can see that that helps me get rid of these fractions, because the only thing that's going to be left now when everything has canceled is 3x, you can see that on the left side, equals 9 on the right side. So to get my x variable by itself, I need to divide by 3. And 9 divided by 3 is going to give me 3. So my solution here, I believe, is x equals 3. Now to check that and to make sure that we did that correctly, we want to go back and plug that in for every variable of x in our original expression. And make sure that we get a true statement. If we get a true statement, meaning something like a number equals that same number, that is a true statement, then we have done our process correctly and we've solved correctly. So we said our solution was 3. So we have 3 over 3 minus 2. I'm inserting a 3 everywhere there's an x. Equals 9 over 3 squared minus 2 times 3. Alright, so I've got 3 over 1 equals 9 over 9 minus 6. 3. And you can see that both sides are going to be equal. 3 equals 3. So whatever number you end up with, as long as it's equal to itself and it gives you a true statement, that means the solution that you found is correct. Alright, so let's take a look at an expression here that is an adding expression, a rational adding expression, and we've got an equation that needs to be solved for x again. We're going to have the same strategy. We're going to look across our denominators and see what can be factored first. So the only thing I can see is over here on the right hand side. That one could be split apart into two separate groups here. X squared minus 6x plus 8 could factor into x. I believe it's going to be 4 and 2. We're looking for the two numbers that multiply to give us 8 and add to give us negative 6. So we're going to use 4 and 2, but they're both going to need to be negative for the reason of adding together to become negative 6. Alright, so the least common multiple is what we're looking for next. We need to have each different piece that we see in the denominator. So I see an x minus 4 piece and an x minus 2 piece. So I'm now going to multiply both of those by each numerator. So let's set that up. So we've got 1 by all of this. least common multiple, over my x minus 4, plus x times each of these again, over x minus 2, and then the right hand side 2 gets multiplied by everything as well, all over the same least common multiple. Alright, so we've got it all set up here, and remember the reason why we're doing this is so that we can get rid of our fractions. So everything should cancel as far as leaving us no denominators, and I believe we have it. So let's rewrite what we have left. We have x minus 2 plus x times x minus 4 equals 2. Alright, so we're going to continue to solve this for x. So we're going to move to the next slide. X minus 2, let's rewrite. Take a look at it. Plus x times x minus 4 was 2. Alright, so we've got a little bit of distributing to do in this second part of the expression here. So we're going to carry over our x to each item in that group, so we'll have x squared minus 4x equals 2. Okay, on the left hand side we're going to look for like terms that can come together. We have a couple of those. We've got to get those together before we can begin to isolate our x. Alright. So 1x minus 4x gives me negative 3x. Got my x squared, got my minus 2 still, and my 2 over on this side. Now, it looks like what is forming is a quadratic. That's something with a power of 2 that's going to need to be factored and solved that way. So what we're going to do when we see that start to happen is move everything to one side and get our equation set equal to 0. So I'm going to move this 2 over here, have it set equal to 0. That way I can factor and continue to solve. So let's write this in standard form. I'm going to put the x squared term first, minus 3x minus 4 equals 0. Okay, so now we need to factor, and it looks like we're going to have two solutions. Alright, so this is going to factor into x plus 1, this expression here, times x minus 4. And if I need to find the solutions from those two pieces, I can set each one equal to 0. So x plus 1 equals 0 would give me an x value of negative 1. And then x plus 4 equals 0, or minus 4, would give me an x value of positive 4. Okay, so take a look here. We are saying that we have two solutions here because we had a quadratic. So solutions of negative 1 and 4, we believe, are the answers to this expression. But we want to check, just like we did last time, we want to plug them in and make sure that they both are actually solutions. Because what happens sometimes is we end up with solutions that are called extraneous solutions, which means they don't actually give us a true statement when we plug them back into the original problem. That can happen sometimes. So you always want to check. So if you were to go back in and plug in our first solution we said, which was a negative 1, everywhere you see an x, we would put them in all these places. And then we would end up with a true statement. Actually, 2/15 equals 2/15. And remember, I told you any number that you end up with is fine, even a fraction, as long as you do get a true statement. So negative 1 is a solution, an actual solution. But if you were to go back in and test our other number of 4 in each of these spots for x, you are going to find that you do not get a true statement. So 4 is not a solution. It is actually an extraneous solution. It is an extra false solution that sometimes comes out of the operations that were needed to carry out the problem. So this concludes our lesson on solving rational equations.